this is probably one of the easiest things for today's lesson. So if you come across something that's squared and it's equal to whatever it might be equal to, let's just say 81 for the sake of having a nice easy problem. If you want to solve this, how can you undo a square? Hint is in the name of the problem.
Square root.
Square root. Okay?
Yes.
Now, what do we know the square root of 81 is? 9. Here's the only thing. Little thing. Huh? I am young?
No.
Oh, okay. I was looking at my Alright, when you solve and you take the even root of something, you get a symbol that we probably haven't encountered much before, and you need to put a plus or minus out front. Here's why. Think backwards for a second. Remember that the original problem was x squared equals 81. Is 9 times 9 81?
Yes.
Is negative 9 times negative 9 81? Also yes. So that's why we need that plus minus symbol out front. So if you are solving and you square root in the solving process, then you need the plus minus symbol out front. Solving by factoring. So if you want to solve by factoring, let's talk about the steps here. Step number 1 would be to factor. And then step number 2 is going to be to use something called the zero product property. And I'll show you what that is. Alright, so we're going to use the zero product property. So, let's say I have x squared plus 5x plus 6 equals 0, and I am asked to solve this. And again, let's say I don't really want to graph it. That's not my favorite thing to do. Let's go ahead and factor. Do you agree that's a trinomial? 3 terms. So we're going back and using some of those skills that we learned before. I know x times x takes me back to x squared. We're thinking about the list method right now. What are my 2 numbers that multiply to 6 but can add or subtract to 5? 3 and 2. If you didn't think of 3 and 2, kind of sit back and look at that for a minute and make sure that makes sense. 3 times 2 will multiply you to 6. 3 plus 2 will get you to 5. Now, do you see how you have, I kind of sound like Dr. Seuss when I do these problems. You have thing 1 and thing 2. Yeah. You have thing 1 and thing 2, and they multiply to give you 0. What's the only way to get 0 when you multiply? Multiply by 0. So either thing 1 has to be 0, or thing 2 has to be 0. What value of x would make this pink parentheses 0? 0 plus 3 would be 3. Negative 3. So negative 3 is one of my solutions. What would make the yellow parentheses 0? Negative 2. So these are my 2 solutions. And remember yesterday we talked about the types of solutions we could get. We could get 1 solution when the vertex lives right on the axis. We could get 2 solutions when it has 2 intersecting points. Or we could get no solutions when the vertex is, say, above and it opens up. Or it's below and it opens down. So there are situations where we can get no solution. So we're going to factor. And then do you see how it's basically taking out the opposite? Okay? Alright. Last thing we're going to talk about, and then we're going to do some more examples. So again, we're kind of like front loading everything and making sure we know some of this information before we get into the problems. Writing a quadratic equation given the zeros. So not only can I solve a quadratic equation, but I can also work backwards and figure out what equation gave me certain solutions. So, let's say I told you that there's a quadratic equation with solutions -5 and 2. Okay, so there's a quadratic equation out there walking around in the world, and it has solutions -5 and 2. And my question to you is, what is the quadratic equation? Okay, think backwards from what we just did. So it's the same skill, but in reverse. If -5 is a solution, what parenthesis would it have come from? So think backwards. So -3 was a solution because we had this parenthesis. If -5 is a solution, it would have come from x plus 5. Do you need half? Yeah. Okay, give me 1 second. If +2 is a solution, what parenthesis would it have come from? X minus 2. And now we're going to FOIL. You get a head start on me and start FOILing. Where are you headed?
Lake Training.
Yep, FOIL it out, multiply it out, double distribute, however you want to think about it. Yep. Alright, so x times x, x squared. X times -2, -2x. 5 times x, 5x. 5 times -2, -10. Do I have like terms that I can combine? Yep. Yes. In the middle, I have a -2 and a +5. So I get x squared. What's my next term when I plus 3x minus 10? Yep, because it's a +5 and a -2. Okay, so those are the 3 things we're going to be doing today. Nothing beyond that. So you're going to either encounter problems where you have to square root to solve, where you have to factor to solve, or where you have to work backwards and figure out what was the problem that it came from. Okay, so that's what we're going to encounter. So let's do a couple more examples to make sure that when you get to the homework, it'll feel like this is okay, I can do this. Number 1 is like example 1. What would I do to solve for A? Square root. When I square root each part, A equals, what's the square root of 64? Thank you. 8. And what symbol do I have to put in front?
Plus minus.
Plus minus. Because +8 squared is 64, but -8 squared also 64. Okay. Questions on that one? Nope. Let's see if there are any others like that, because there are a couple on the back. Let's see. Let's go to number 7. Go to number 7, because 7 is similar to that. So let's knock out all the problems that are the square root problems to solve. Look at 7 for a second. Do you see how there's only a term squared? Do you see how there's a 121 out front? If I want to get J alone, I would divide by 121 first before I would square root. So J squared equals 25 over 121. Again, we're dividing away the 121. It would be multiplied. I do the opposite, which is division, to get it away. Question? Yes. How would I undo the square now that it's alone? Square root. Remember when we square root, we get our fancy plus minus symbol. Now, square rooting a fraction seems super ugly at first, but look at your numbers. What's the square root of my numerator? What's the square root of 25? What's the square root of 121? 11. So this would be my final answer. And the good news is they're going to give you nice numbers like that. So if it does end up being a fraction, you should be able to easily square root the top and the bottom. Okay, so those were the only 2 problems of that type. Also, you can cross out number 9 because that doesn't even fit into this section because it has 3 solutions. We're not dealing with anything with 3 solutions. That's just silly. Okay, go back to the first page. Let's find some oh, I see one more. I see one one more. Do you see one more?
3.
Oh, yeah, but it's got a C. Just kidding. Now that I look closer, it's got a C with it. So it's okay. Let's keep going. What does that even mean? So if I see something squared and then a plain old number, that's the type of problem I was just doing. So at first glance, I was like, oh, number 3 is 1, 2, but do you see how it has a C?
What does the C do though? How does it change it?
So if there's another variable, it's going to impact it. I'll show you in a minute. Okay? So the types of problems you're looking for are there's only one variable and it's the variable squared.
Okay.
No other variables anywhere in the problem. Okay. I hate number 2. Okay. Let's go to 3. Just being honest. Okay, number 3. Do you remember yesterday we talked about the fact that we wanted everything set equal to 0? Is this set equal to 0? No. So the first thing I'm going to do is add over the 10c. So I get c squared plus 10c equals 0. This is a factor and solve question because it's not just a c squared. There's more stuff. It's not a trinomial. Agree?
Yeah.
Okay. So I'm going to see, it's not a difference of squares either because it's not a difference and I don't have perfect squares. But do you see how they both have a c in common?
Oh,
So
yeah.
this is a like term one. So I'm going to pull out a c. Okay, so I've got this. C times what would give me back my c squared? C. C times what would give me back 10c? 10. Alright, again, we're going to play the thing 1 and thing 2 game. So this is thing 1, and if it helps you, you can highlight and color code and do all this stuff too. If it doesn't, then don't. Here's thing 2. What would make thing 1 0? If c was 0, because 0 times all the rest is 0 out. So one of my solutions is 0. What would make this parenthesis, the yellow parenthesis, 0 if c was negative 10? Because negative 10 plus 10 would add me to 0. So you're looking for what we call the additive inverse there. Alright, 4 and 5 are the same that we can factor and solve. For this one, again, I need to set it equal to 0. So y squared, I'm going to move the 19y over. Again, if it's not set equal to 0, you want to do that first. So let me fix number 5 while I'm at it. So again, you want all your stuff on one side together and then have it set equal to 0. That's the most conducive for us to solve. Yes?
Why don't you put negative 19 in front of CC? Oh, why don't you put 5?
Because it's got a y with it. Remember, we like to go, standard form says order of like decreasing power. So I have squared, and then I have a 1, and then I have nothing.
They both have power.
No, this has a power of 0 because there's no variable.
Oh.
If it had a variable, then I would actually combine those like terms, right?
Yep.
If I could. Okay? Ooh, I'm already trying to think here. Somebody help me. The hamster keeps falling off the wheel today. What are my, I've got 2 numbers. They multiply to 60 and add to 19. I'll give you one of them. 15. Oops, sorry, that's not up high enough for most of us to see. What's the other one? 4. Is 15 times 4 60? Okay, let's be careful about our signs though. If I did 15 plus 4, that'd get me 19. And I need a negative 19. So what should I do? Minus where? Both of them. Good. Both because,
Wait, why?
let's talk why. Negative 15 times negative 4 will give you a positive 60. Yes? A negative times a negative is a positive. So that would give me a positive 60. Negative 15 minus 4 more, will that get me to negative 19? Yeah, so that works. Again, we're playing the Dr. Seuss game. We've got thing 1 and thing 2. Like I said, feel free to color code if it helps you. If it doesn't, don't. It's not required in any way, shape, or form. Okay, sorry, apparently I need sound effects to color guide. Alright, what would make this 0? What value of y? 15. Positive 15, right? Because then when you think about it, 15 minus 15, would that be 0? Yup. That's how you can double check yourself. What value of y would make this parenthesis 0? 4. A positive 4, because 4 minus 4 is 0. So these are my two answers. And typically, I don't use a lot of punctuation in math, which is good because punctuation was never my strong suit. But this is a spot where I use a little bit of punctuation. I put a comma. We're not going to write the word and because y cannot be 15 and 4 at the same time. It's going to be one or the other. It can be 15 for a solution or it can be 4. It can't be both. Right? Okay, next one. 2 sets of parentheses. Set equal to 0. G times G is G squared. What would multiply to 42 but add or subtract to 1? 6 and 7. Okay, let's think about this more. We need a negative 42 when we multiply, but a positive 1. So what signs do I want? Minus 6 plus 7. Okay, step back and look at that if you didn't come up with that quite as quickly. So negative 6 times positive 7, is that going to give you negative 42? Negative 6 plus 7, is that going to give you 1? Yes. And remember, we have this nice property called the commutative property, so these 2 sets of parentheses could have been flipped, and that would be fine. Okay, let's play thing 1 and thing 2 again. What would make the first parenthesis 0 if G were what? 6. G were 6. Perfect. Let's look at the second parenthesis now. What would make the second parenthesis 0? Negative 7. And again, like I said, I'm not a big punctuation person. This is a spot we use it though in math. We use a comma. And that's showing I could have either solution. Again, G can't be 6 and negative 7 somehow miraculously at the same time. It's not a thing. Okay? It's one or the other. Okay, go ahead. Last one, very similar. Why don't you try this one on your own and see if you can do it on your own. You see how it's not set equal to 0? That's problem number 1. You try it. I'm going to freeze my screen. Try it on your own. We're still going to go through it. Relax. We're still going to go through it. Okay, you try it. I'm going to try it. We're going to meet back up and see how we did. No, so you're going to have, it's Miss Fisher, have Miss Fisher go grab it from the house. Because that's where it's living right now.
Thank you very much.
Yeah, this is your first one on your own. I'm not expecting it to be perfect. Try it. Oh, you did? Good. That's fine. You tried and you gave it an effort, right? That's what I'm asking for right now. I'm not asking for perfection. Asking for a try. Okay, I'm going to give you another couple of seconds just to make sure everybody's had enough time to try it. Yeah. We're not going to do 9, but we are going to do 8. 8 makes sense to do. 9 has 3 solutions, and that's not even a thing in quadratics, so I'm not even sure why it's there. Well, I mean, not this year. Yeah. That's a good way to answer that. Thank you for that suggestion.
You're welcome.
Here we go. How'd we do?
What?
Okay, wait,
I got the numbers right, but I had them flipped. I had -13.
It should be -13. Well, it should be K minus 13.
Yeah.
Because you need a -10. Oh, I lost the K in the middle.
Why
Hold
is
on.
another one a -2?
Hold on. Too much talking. Say that again.
Oh, never mind. I said why is another one from negative and one's positive, but I forgot I have to add them.
we basically are mistakes.
Do we see it if we made a mistake? And if you were close to being the whole way there, that's perfect. Again, I'm not asking for perfection on it. I just wanted to kind of give you a little more like leeway there and see what we could come up with without me. Alright, last one wants me to find the equation that it came from. Remember we talked about that being a thing as well. Do you see how this is a solution? Where does that solution live? In terms of x, it lives where? 1. In terms of x, where does this solution live?
3.
-3. Okay. If 1 is a solution, what parenthesis did it come from?
What?
Think backwards. If -3 was a solution,
Interruption at this time.
oh, I bet it's
Please
tennis.
release the girls varsity tennis players.
There it is.
It's the right one.
It was ESP. See how I did that? Genius.
Did you hear it?
Just kidding.
Did you
No,
hear
I
it when
did
they
do it
messed up? That was
earlier. I
hilarious.
did. Okay. I was trying to pretend like I sensed it though for the video. You know, I was trying to be cool.
Well, you never
That's
post
fine.
these. You never post these. It's always a different one. Like
No, I
one
post
from
them.
previous years. The one that you show us in class
No.
is from previous years.
No, no, post it. I usually post them. Oh. Okay, if -3 is a solution, it's because it came from x plus 3 as a parenthesis. If 1 is a solution, what did it come from? X minus 1. If -3 is a solution, what did it come from? X plus 3, and now we're going to FOIL. X times x. X times 3. 3x. -1 times x. Yep, and -1 times 3. -3. Like terms are situated nicely in the middle again. If I have 3 x's and somebody takes 1 away, how many do I have left? So this is going to be my final answer. So this equation would have given me these 2 solutions and this graph.
I don't really understand that.
Ta-da! Okay,